Dear students, here we'll take two different traversal methods in graph. Those are BFS, breadth first search, DFS, depth first search. We'll take with an example. We'll apply BFS algorithm for this one. The first step is to create adjacency matrix. This is adjacency matrix. The adjacency matrix has got two information. One is that node and its neighboring node. For example, for A, neighbors are B, C, D, and E. For B, the neighbors are A is neighbor, D is neighbor, F is neighbor. For C, A and G are neighbor. For D, A, B, and F are neighbor. For E, it is A, G are the neighbor. For F, it is B and D. For G, it is C and D. The first step is to create adjacency list. So here we have to start traversal. Traversal means visiting all the nodes exactly once. Right now we have not started anything. So you set all the nodes to unvisited state, ready state. Okay. Means yet to complete that work. Next step. So you have to choose one node as a starting index. In this case, I'm going to choose A as my starting index. Here information generated here. A will spread the information to all its neighbors in one stretch. Its neighbors like B, C, D, and E. Then to reach G, anyway, directly it is not possible. From which node of A's neighbor that node can be released. So here F can be released. F directly cannot be reached from A, but F can be reached from B. B is the immediate neighbor for A from which you can reach F. The same way G you have to reach, but directly there is no method. Either you have to go through E or C, but the first one C. Okay, this is a called this is called propagation, backtracking, backtracking. Okay, so to do this now we need this structure called queue. Insertion will take place in the rear end, deletion will take place in the front end. I'll be choosing index A, that is as a starting point. Once that is removed from the queue, you can say that it is finished. No more attempt is required to reach that node A. The first node that we are going to start is A. Once you remove that from the queue, all its neighbors you have to add. Only if they are for the first time, not yet visited. Okay, repeat. If already visited or in the queue, no need to touch any. So B, C, D are added to the queue. The next in the front side B we have. For B, its neighbor you have to add. A, D, F are the neighbor. A already finished. D there in the queue. F is the new one. So here you can see after reaching B, all its neighbors are added. C, D, E, F. F is also a neighbor. Then in the next time you have to remove C. You have to remove C because C is also a direct neighbor, immediate neighbor. For C, A and G. A is already finished. G is the new one. So you add it. Okay. Then in the front side we have D. D you have to remove. Its neighbors are A, B, and F. A is finished. B is finished. Then F is there in this text. So no changes in Q. Okay. Then the rare next element is E. E is the next element. E can also be reached from A. E neighbors are A and G. A and G. A already finished, G already there in the stack. So no changes in the Q. No changes in the Q. Next time, front element is F. F to be removed. F is removed. All its neighbors B and D. B already finished. D already finished. So no change in the Q. Then last one element is there, that is G. G you have to remove. So this process has to be completed till all the elements, all the nodes are visited. G is the last node to visit. Okay. As I told, from A you can reach B, C, D, and E directly. But how about F and G? F and G directly not reachable from A. But what? But how we can reach F? So F was added when you are looking, when you removed, when you added the B to the queue, all its neighbors added. F is neighbor of B. So We know how to reach to B from A, then from this we can say that F is also reachable from B directly. A to F there is a path, but via B. That is the meaning. In the same way, G was added. G was added because of C. C neighbor is A and G. A already finished. J is a new element that is added when you consider that to C. Okay. So nodes reachable spanning tree A to B, A to C, A to D, A to E, then to F like this, G like this. This is a spanning tree. From A we can reach directly to B, C, D, E. Cost of reaching that node is 1. Cost of reaching to the next level maybe 2, because the previous level, previous height and the next one. This is about BFS search algorithm. Next we'll go for the DFS for same, but here I'm going to take starting node as F. But the logic is that you know, the original information started here, the place where the information started. It will be delivered to its neighbor P. Only one neighbor at a time. From F, the data will go to one of the neighbor. It can be B or it can be D. It can be anything. It can be anything. It can be B or it can be D. Here I took D. After D, the data will go to A. A. After A, the data will go to E here. After E, data will go to G. After G, data will go to C. Okay. Next, here B is not reachable, but it is possible with a vector from EX. That is not there in the slide because of the space I removed them. So for this, we can use stack data structure. Initially, it is empty. I'll be adding my starting point, that is F to the stack. F to the stack. Once you remove, that means that is the node that is just now visited. It's completed. The status is completed. Yes, this is a standing point. What are its neighbors? What are its neighbor? For the F, the neighbors are B and D. B and D. In that D is the top point. We are going to remove the top element of the stack. D is removed. For D, A, B, F are the neighbor. A, B, F are the neighbor. B already there, F is removed. So remaining thing that you have to add, that is A. The next element is F, then D, then A. All its neighbors you add B, C, D, E. D, B, there is that. C also like that. All its neighbors you have to add. Well, here E at the top of the stack. Always in this process, top of the stack will be removed. E will be removed here. E will be removed next element. E will be removed from the stack next time. What are its neighbors? A and G. But A already visited, G unvisited. You have to add only G. The next node that we are going to visit is G. G is removed from the stack. G is removed from the stack. When you remove that G, the stack content will be B and C. See, the neighbors are C and D. In that, C is there in the stack, E is finished. So no changes will be made in the queue. B and C. Next element that will go is C. A and G. A is also over, G is also over. Nothing, no modification. No modification. After that, we are going to remove C. C, its neighbors A and G. A is finished, G is also finished. No changes in this queue. The last element is B. So this process has to be completed, has to be repeated till no more element to consider or queue is empty. The spanning tree looks like this. We are starting from F, F to D, D to A, A to E, E to G, G to C. P is B is reachable only through F. This is the spanning tree for BFS. Thank you.